Okay, if you are in Math 7, we are 7 Excel, we're working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing Lesson 5.1, Example 2, and it can be found on page 205. Okay, so we are still working on solving systems of equations by graphing. And remember, a system of equation means more than one equation. So we are looking for a point or a solution set that will solve each equation. So there should be one point or one solution set that will solve each equation. So the first equation we have is y equals negative 4x minus 7. So I need to graph this. Okay, my y-intercept is negative 7. So this is telling me where I start. 1, 2, 3, 4, 5, 6, 7. So my y-intercept is negative 7. My slope is negative. That means it's going in this direction. It's going down. And it's 4 over 1. So I'm going to go down 4. 1, 2, 3, 4, and over 1. Down 4 over 1. Now that's kind of taking me far off my graph. So I'm going to follow it in this direction. Up 4, 1, 2, 3, 4, over 1. Up 4, 1, 2, 3, 4, and over 1. And I'm going to connect my points. So this is like what we did yesterday. Now my second equation, because we're talking about a system of equations, which means more than one. My second equation is x plus y equals 2. Okay, exactly how am I supposed to graph this? I can create a table, or I can convert this to slope-intercept form. So we can take this equation and we can convert it to slope-intercept form. Y equals mx plus b. Okay. So in slope-intercept form, y is isolated. So I need to rework this so that y is isolated. So I need to get y by itself. So I'm going to subtract x from this side. What I do to one side, I must do to the other. And I now have y equals negative x plus 2. This is in slope-intercept form. Y equals mx plus b. So now I can graph this. So my y-intercept is positive 2. My slope is negative, so that means it's still going down, and it's negative 1 to 1. 1 over 1, okay. Down 1 over 1, down 1 over 1, down 1. Oh, the more I go in this direction, the further away I get from here. So I'm going to follow this direction. And it looks like if I extend my line here, it looks like both lines intersect at this point. And that point looks like it would be 1, 2, 3, negative 3, 1, 2, 3, 4, 5. So it looks like they both intersect at -3, 5. But that's kind of far out there on the graph. I'm not exactly sure. So I'm going to check my work. Is -3, 5 a solution? I don't know. Let's substitute it in and see. -3, that's my x, there's my y. So let's do some substitution. I have my first equation. And we're going to substitute x and y in here. So 5 equals -4 times -3 minus 7. So 5 equals -4 times -3 is positive 12 minus 7. And 12 minus 7 is 5. This is true. Therefore, -3, 5 is a solution. Yay. But now let's plug this point or substitute this point into this equation. Now, when I'm working with this equation, I can use this, x plus y equals 2, or I can use this, y equals -x plus 2, because they are equivalent equations. So I'm going to use the original equation. It just looks easier. And I'm going to substitute this point into here. So x is -3 plus y is 5 equals 2. -3 plus 5, 2 equals 2. Look at that. That is true. Therefore, -3, 5 is a solution. So that gives us our big, huge therefore. Therefore, -3, 5 is a solution to this system of equations. So it's exactly what we did yesterday. This is just like what we did yesterday, only we may have to convert or change one or both of the equations into slope-intercept form. That's the only difference. So let's do one more. Let's do one more. Okay. So they give us this equation, y minus x equals 5. Okay, I'm not exactly sure how to graph that. It's not in slope-intercept form. So I'm going to convert this into slope-intercept form. I want this to look like y equals mx plus b. So I'm going to convert this. I need to isolate my y. Okay. So let's subtract x from this side, subtract x from this side. -y equals -x plus b. I don't like -y. Y needs to be by itself. So technically, this is multiplying times -1. Remember that -1 is there. So technically, this is saying -1y equals -x plus b. I don't like that. So I've got two things I can do. I can multiply this by -1 because a negative and a negative is positive, right? So let's go with that. I think that's the easiest way. So let's multiply this side by -1 and multiply that side by -1. A negative and a negative is positive. So y equals -1 times -x is positive x. And -1 times positive 5 is -5. So basically, all we've done is just switch the signs of everything. Multiplying by -1, we've switched the signs of everything. This is now in y equals mx plus b format. I can graph this. So my y-intercept is at -5. My slope is positive, and it's going to be positive 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. There we go. Okay, now we need to graph our second line because we're talking about a system. And our second line is negative 3x plus y equals negative 1. So once again, this equation is not in slope-intercept form. I need it to look like y equals mx plus b. I need to get this into this format. So I need to isolate my y. I'm going to add 3x. What I do to one side, I must do to the other. So y equals 3x minus 1. This is now in slope-intercept form. I can now graph this. So my y-intercept is negative 1. My slope is positive, which means it's going to go up, okay? And it's positive 3 over 1. So up 3 over 1. Up 3 over 1. Ah, the further up I go, the further apart my lines go. So let's try switching it. Down 3 over 1. Down 3 over 1. Oh, look at that. Let's connect our points. And it looks like right here is where both my lines intersect. And that looks like it's, let's see, negative 2, 1, 2. And it looks like 1, 2, 3, 4, 5, 6, 7. Negative 2, negative 7. So it looks like my solution is negative 2, negative 7. But it's kind of far down here, and I want to check just to make sure. So I want to know, is negative 2, negative 7 a solution? So we're going to substitute negative 2 and negative 7 for x and y. Now up here, I can use this equation, or I can use this equation. I will get the same answer either way. I'm going to use this one because it looks like it's easier. And then I'm going to substitute negative 2, negative 7 equals 5. Negative 2 plus 7 equals 5. Negative 2 plus 5 equals 5. This is true. Therefore, negative 2, negative 7 is a solution. Now let's substitute into the next equation. And I can use this equation or this equation. I can use this or this. Now, this one, I don't know. I think I'm going to use this one. To me, this one looks easier to use. So this is the one I'm choosing. And now we're going to substitute. Negative 7 equals 3 times negative 2 minus 1. Negative 7. 3 times negative 2 is negative 6 minus 1. Negative 7, it's a 1. Negative 6 minus 1 is negative 7. That is true. Therefore, negative 2, negative 7 is a solution. So, negative 2, negative 7 is a solution. Negative 2 is negative 7 is a solution. So, yes, negative 2, negative 7 is the solution for this system of equations. So that's what we're doing today. It's the same thing we did yesterday, only sometimes we may need to convert the equation into slope-intercept form. You guys got this.